X-ray tube. A tube is an air-evacuated device in which the X-rays are produced. Its characteristic is to produce electrons, attract electrons, physical protective casing, and radiation protection. Electrical device used for the generation of X-rays. This is accomplished by the acceleration of electrons and then suddenly decelerating them. The energy of the X-rays is dependent on the kinetic energy of the electrons. The cathode, a negatively charged electrode. The cathode has two types. First is what we call the Coolidge Tube. Historically, X-rays were discovered radiating from experimental discharge tubes called Coolidge Tubes, invented by William Crookes and others. Commonly known as Coolidge Tubes, it is used till 1920. The next one is what we call the Coolidge Tube, or a stationary anode tube. Crookes tube improved by William Coolidge in 1913, called Coolidge Tube or hot cathode tube. Characteristic of it features a high vacuum, heated filament, and thermionic emission. Anode. It also has two types. First is the stationary anode X-ray tube, and the second one is the rotating anode X-ray tube. The rotating anode tube is an improvement of the Coolidge tube. The reason behind the introduction of rotating anodes is related to the dispersal of heat. All that energy coming from the anode side from the cathode side produces a huge amount of heat. If that heat keeps hitting the same spot over and over again, as in a stationary anode tube, eventually the surface of the anode can deform and the angle of the X-ray beam will shift, reducing dose efficiency and the overall image quality the tube is capable of producing. In the case of rotating anode tube, the heat of the incoming cathode beam is dispersed eventually across the entire surface of the anode as it rotates. This enables rotating anode users to perform longer scans and at higher doses. Line focus principle and the Anode Hill effect. Line focus principle. The principle that viewing a slope surface at an angle reduces its apparent size. In an X-ray tube, the angling of the anode results in the effective focal spot being smaller than the actual focal spot. In general, an X-ray beam intensity is not uniform. When it focuses to a target, a conical shape appears. The intensity of the beam from the positive anode side is lower than the intensity from the negative cathode side, because the photons created when the electron strikes the target have a longer way to travel to the rotating target on the anode side. Anode Hill effect. Varying the intensity of X-ray at anode side is lesser than the cathode side. Beveled anode absorbs some X-ray photon. This effect is called the Anode Hill effect and refers to the lower field intensity towards the anode in comparison to the cathode due to the lower X-ray emission from the target material at angles perpendicular to the electron beam. Care of X-ray tube. Warm up the anode following manufacturer's recommendation. Minimize the filament boost time or the preparation time. Use lower tube current. Follow rating chart. Do not exceed anode thermal capacity or heat dissipation rate of the target. Do not make high MA exposure on cold target. Do not rotate the tube housing rapidly from one position to another. Cathode is the negative side of the X-ray tube and consists of the following two parts. First is the filament. Filament is a coil of wire usually 2 mm in diameter and 1 or 2 cm long. The filaments are made of tungsten. Filament must be able to boil off electrons, or we can also call it the thermionic emission. Next is the focusing cup. The filament is embedded in a metal cup called the focusing cup. The purpose of the focusing cup is to guide the electron stream to the target area on the anode. Because of the tremendous amount of heat that is generated at the cathode side, the structure is made of tungsten, which has excellent thermal properties. Anode. The anode is the positive side of the X-ray tube. Electricity is conducted and radiates heat and contains the target. The anode must be a good thermal dissipator, because when the projectile electrons from the cathode interact with the anode, more than 99% of their kinetic energy is converted into heat. This heat must be dissipated quickly. Most common material used is tungsten, but copper, molybdenum, and graphite are also common anode materials. Conclusion: Master is not about perfection, but the process, a journey. So let's be sure there's going to be more advanced technology, and there will be X-ray tubes with better heat dissipation and lesser patient dose.